If you are looking for low-voltage DC motors in the 12 to 24 volt range, with a power output of 1 to 5 horsepower and a speed of approximately 5,000 rpm, there are several potential sources to explore. Firstly, consider online retailers which offer a wide selection of industrial and electronic components. Amazon Industrial is a good starting point. They often have a variety of DC motors available. Another online retailer is Grainger, which carries a range of electric motors, including DC motors. Digiki is another resource specializing in electronic components and offering a selection of DC motors which can be filtered by voltage, speed, and other specifications. Secondly, explore direct manufacturers of DC motors. Fitmer Motors is a company that designs and manufactures DC motors for various applications. AimTech Precision Motion Control is another manufacturer that provides DC motors and related products. Portiscap specializes in miniature and small DC motors. Maxon Motor is known for its high-precision DC motors and drive systems. When selecting a motor, keep in mind a few important considerations. Firstly, decide whether brushed or brushless DC motor is more suitable for your application. Brushed DC motors are generally less expensive but require more maintenance due to brush wear. Brushless DC motors offer higher efficiency, longer lifespan, and reduced maintenance. Secondly, carefully check the motor's torque and speed specifications to ensure they meet the demands of your invention. The motor should be able to deliver the required torque at the desired speed. Thirdly, determine if you need any additional features such as built-in gearboxes or encoders. A gearbox can increase the motor's torque output while reducing its speed. An encoder provides feedback on the motor's position and speed, which can be useful for precise control applications. Finally, if you have specific requirements that are not met by standard off-the-shelf motors, consider contacting manufacturers directly to discuss custom designs. They may be able to tailor a motor to your exact needs. When evaluating DC motors, pay attention to their specifications and ratings. These include voltage, current, power, torque, speed, and efficiency. The voltage rating indicates the required input voltage for the motor. The current rating specifies the amount of current the motor draws at its rated load. The power rating, typically expressed in horsepower or watts, indicates the motor's mechanical output power. Torque is the rotational force that the motor can produce, typically measured in Newton meters or pound-feet. Speed is the motor's rotational speed, usually expressed in RPM. Efficiency is the ratio of mechanical output power to electrical input power. Also consider the motor's frame size and mounting options to ensure it can be easily integrated into your invention. Pay attention to the motor's operating temperature range and cooling requirements. Some motors may require additional cooling to prevent overheating. Check the motor's ingress protection rating, which indicates its resistance to dust and moisture. Higher IP ratings offer greater protection in harsh environments. Review the motor's performance curves, which show its torque, speed, and current characteristics at different operating points. These curves can help you determine if the motor is suitable for your application's load profile. Furthermore, consider the motor's control options. Some DC motors can be controlled with simple voltage or current control, while others require more sophisticated control schemes such as pulse width modulation or field-oriented control. Look for motors that are compatible with your chosen control system. Investigate the motor's electromagnetic compatibility performance to ensure it does not interfere with other electronic devices in your invention. Also consider the motor's noise level, especially if your invention is intended for use in quiet environments. If you are using a brushed DC motor, check the brush material and lifespan. Carbon brushes are commonly used, but other materials such as graphite or metal graphite may offer improved performance in certain applications. If you are using a brushless DC motor, check the type of magnets used in the rotor. Rare earth magnets such as neodymium magnets offer high performance but can be more expensive than ferrite magnets. Ensure that the motor meets any relevant safety standards and certifications such as UL or CE. These certifications indicate that the motor has been tested and found to be safe for use in its intended application. When choosing a motor supplier, consider their reputation, experience, and customer support. Look for suppliers who offer technical assistance and can help you select the right motor for your needs. Ask for references and read customer reviews to get an idea of their level of service. Obtain detailed specifications and data sheets for each motor you are considering. These documents should provide all the information you need to evaluate the motor's performance and suitability for your application. Compare the prices of different motors from different suppliers. However, don't base your decision solely on price. Consider the motor's performance, reliability, and features as well. Order samples of the motors you are considering and test them in your application. This will allow you to verify their performance and identify any potential issues before making a large purchase. Keep in mind the motor's maintenance requirements. Brushed DC motors require periodic brush replacement, while brushless DC motors typically require less maintenance. Consider the availability of spare parts and service support for the motor. Choose a motor supplier who can provide timely support and repairs if needed. Ensure that the motor is properly protected from overcurrent and overvoltage conditions. Use appropriate fuses or circuit breakers to prevent damage to the motor and other components. Properly size the motor to avoid overloading it. Overloading can cause the motor to overheat and fail prematurely. Use appropriate wiring and connectors to ensure a reliable electrical connection to the motor. Poor connections can cause voltage drops and reduce motor performance. Follow the manufacturer's recommendations for motor installation and operation. Incorrect installation can damage the motor and void the warranty. Regularly inspect the motor for signs of wear or damage. Replace any worn or damaged parts promptly to prevent further problems. Keep the motor clean and free from dirt and debris. Dirt and debris can reduce motor performance and lifespan. Lubricate the motor bearings according to the manufacturer's recommendations. Proper lubrication is essential for smooth and reliable operation. Monitor the motor's operating temperature. Overheating can indicate a problem with the motor or its load. Consider using a motor controller to provide precise control over the motor's speed, torque, and direction. Motor controllers can also provide protection against overcurrent and overvoltage conditions. When selecting a motor controller, ensure that it is compatible with the motor's voltage, current, and control requirements. Consider using a variable frequency drive to control the speed of the motor. Variable frequency drives can provide smooth and efficient speed control over a wide range. When using a variable frequency drive, ensure that it is properly programmed and configured for the motor. Consider using a programmable logic controller to automate the control of the motor and other components in your invention. Programmable logic controllers can provide sophisticated control and monitoring capabilities. When using a programmable logic controller, ensure that it is properly programmed and configured for the application. Consider using a human-machine interface to provide a user-friendly interface for controlling and monitoring the motor. Human-machine interfaces can display motor status, allow users to adjust motor parameters, and provide alarms for abnormal conditions. When using a human-machine interface, ensure that it is properly designed and configured for the application. Consider using a data acquisition system to collect and analyze data from the motor and other sensors in your invention. Data acquisition systems can provide valuable insights into the performance and behavior of your system. When using a data acquisition system, ensure that it is properly configured and calibrated. Consider using a simulation software to model and simulate the behavior of the motor and other components in your invention. Simulation software can help you optimize the design and performance of your system. When using simulation software, ensure that the model is accurate and validated. Consider using a rapid prototyping system to quickly create prototypes of your invention. Rapid prototyping systems can help you iterate on your design and identify potential issues early in the development process. When using a rapid prototyping system, ensure that the materials and processes are appropriate for the application. Consider using a computer-aided design software to design and document your invention. Computer-aided design software can help you create detailed drawings and models of your system. When using computer-aided design software, ensure that you follow industry best practices for design and documentation. These retailers and manufacturers should be able to provide suitable options for your gizmo or invention requiring a 12 to 24 volt DC motor in the 1 to 5 horsepower range with approximately 5000 RPM.